Hi, good afternoon, everyone. Myself, Mr. Pratik Shah. I'm technology owner of CloudIBN, and we are into cloud and cybersecurity services. So we are a well-known company based in Pune, and we do provide services for cloud infrastructure and cybersecurity like VAPT and SOC. And welcome not taking much time. Welcome all for the webinar on VAPT for application development. And Mr. Gautam will who will be taking this webinar ahead. Very good afternoon, Gautam. Please, over to you, please.
All right. Thank you so much uh, for the opening session. I'm really happy and excited to proceed this session from here now. So I would just quickly like to share my screen once again. Yeah. So I hope I'm audible and my screen is also visible to all the participants. So, as Mr. Pratik has shared, the topic for today is going to be VAPT for application development. So, we are going to understand about what VAPT is, how organizations need to identify and implement a robust application development lifecycle, or we can say a SDLC lifecycle. What are the shortcomings or gaps that can be identified and patched in a timely manner to avoid disastrous cyber attacks and outcomes during this webinar? The agenda is going to be first understanding about VA, understanding about PT, understanding about a SDLC process, which is the software development lifecycle process, then how VAPT or security testing fits in hand to hand in the SDLC process, what are some of the secure coding best practices for developers, and then we'll move forward to a case study and then a practical demonstration followed by Q&A for the participants. Okay, so let us understand about VA and PT. So as the term VA and PT primarily means vulnerability assessment and penetration testing. Now, what does vulnerability assessment primarily means? If we talk about for organizations or any given security team, primarily, vulnerability assessment is the process of identifying any gaps or defects in any given asset of the given organization. If we talk about applications or softwares that are being developed by organizations, here VA would fit in the security team testing out the given applications and identifying the given defects or gaps that can be exploited in real time by threat actors or a malicious attacker. So the overall process of identifying these defects and gaps is termed as VA. There are various tools that are available that can be utilized to perform VA. There are open source tools as well as there are commercial and professional tools that can be utilized to perform this process. Now, once the VA process gets completed, the second stage, I would say, which primarily is the PT stage, which stands for penetration testing. Now, in the PT stage, the security team is going to get involved deeper, I would say, in identifying the overall impact of the given bug or the defect or the gap which was found in the step number 1. So here the team would penetrate through the application by exploiting the vulnerabilities that has been identified in the VA phase. So to see the maximum amount of damage or the maximum amount of impact any external threat actor or an adversary could create on the given application by using that gap or defect is known as PT. Hand in hand, both of these together are referred as VAPT and are a very critical component for any given organizations into safeguarding the cybersecurity posture. Yeah, so we have understood the definition. The primary scope is examining the security weaknesses in the given infrastructure, identifying and classifying vulnerabilities, which is basically the bugs and the defects. The target is to encompass computer systems and networks, that is basically to assess the maturity or overall security standards of given computer systems, be it web servers, be it load balancers, cloud applications, software binaries, thick client, APIs, etc., as well as the network components as well. Due to all of these, we would basically be sure about the overall posture of the given organization and enhance the organization's posture in terms of any defects or vulnerabilities that has been identified to make the organization much more secure. We have understood VA, we have understood PT. In specifically PT, we try to mimic the real life threat actor to see the maximum amount of impact that can be created, and we try to exploit the components of the given systems that have been identified or are in the scope of the process. Generally, in VAPT, there are three different types of security testing that has been done. First is black box, second is white box, and the third one is gray box. The first one, which is the black box approach, primarily means that the security team does not have any given prior information about the target. Okay, no information about the technology stack, no information about the roles, no information about the functionalities or any kind of credentials or test data. Here, the security team is going to test the given application, or I would say would perform VAPT in a manner that a real world threat actor or an attacker would do, because he might also not have any kind of information and he would have to gather this information actively through various techniques. The same thing applies to a penetration tester who is going to perform VAPT. Whereas opposite to this is white box testing, in which the security team would first get all the information regarding the given application, and the information would include the test data, the credentials, the functionalities, information about the database, a technology stack, etc. So here the team would know all of this information. The only objective is to make sure that the security testing is done in a manner with which is basically very thorough, so the pen tester team does not miss out any given critical components or functionalities. Wherein gray box, which is in between the white box and the black box, is the combination of both. That primarily means limited information is being given to the security team, limited information about the target application, about the underlying technology, database information, test data, etc. has been provided. So these are three different uh, types of VAPT that I would say that has been done in real life organizations. Now, as we have understood about VAPT, it is very important to understand that both of these are like a puzzle which fits or which are being done hand in hand, which proactively supports the given organization to make themselves much more secure, identify the gaps in the first phase of VA, and after identifying the gaps, seeing the impact of the gaps by exploiting it into a safe, isolated, simulated manner to assess the overall risk that the organization would possess if these vulnerabilities or gaps are not fixed in a timely manner. So VAPT would overall give an insight for implementation of robust security measures for the given organization. Now we have understood the security component or the security side of any given organization that they need to do, or the necessary actions they need to take. Let us understand about the application development part now. So any organization who is going to develop a given application, software, or a product would have to follow a SDLC process. Primarily, SDLC stands for Software Development Life Cycle. So, SDLC is a 6-step process that is being followed by the given organization in 6 steps or 6 phases, I would say, based on which the complete application is being developed and then it is ready or utilized to be shipped on the production server. So it has to go via different phases. Then the security testing of the given application is being performed on staging or UAT environment, and after which it is ready. After the gaps has been identified, after the security team gives a security clearance and the security sign off, the application goes to the production servers, and from where it is available for public use for all the users worldwide. So SDLC remains a very critical component for any given organization. Now, what are the 6 phases? Let's understand that. So it starts primarily with planning, in which the goals are being defined, the scope is being defined of what needs to be created. What is the objective of the given application? What are the resources that are being going to be utilized to create the given application? So the first step remains the planning, which is the most crucial step, post which is the analysis, in which gathering and analyzing the requirements for the given software that would be needed. For example, here in this case, let's say if an application is being developed that is a vulnerability management application, let's assume that. So the planning phase says, okay, the goals are to create a vulnerability management application software. The scope is going to be that the application takes the input or has integration with different bug tracking tools or softwares. It takes the input from them, populate the data in a beautiful graphical format, tabular format, or a very easy to interact format, and gives it on the dashboard. All this has been identified in the step number or phase number 1. In the analysis phase, the team or the organization's development team is going to identify what are the requirements to implement a given vulnerability management tool. So they would say, okay, so the first requirement that we identify over here is that we need to identify a base technology stack. Maybe we go ahead and create this in Go language, Python, PHP, etc. What are the up-to-date libraries, dependencies? Yeah, so what are the up-to-date libraries, dependencies that are going to be utilized that needs to be identified and noted down? Next is the design, wherein the architecture and design specifications are going to be specified, or the wireframe, I would say, for the given application is going to be planned over here. Next is the actual code base of the design, that, oh, let's specify that this given application is going to have 10 functionalities. So this 10 functionalities code is being written in Python or Go language, and this is how it goes. Like, so here we would see a rough skeleton of the given application into its very premature stage, and identify this is how the functionality primarily would work, or if any APIs or integrations that have been development would work. Then comes the testing part, which is the manual testing. Here, systematically validating.
So मेरा mic है क्या?
If there are any questions, are there
मेरा
any
mic
questions? Okay, no questions. I'll go back to the presentation. Yeah, so in the testing part, we are going to identify the steps that are involved is the manual testing, in which we systematically validate each and every given functionality, each and every given button, each and given dependency that has been going to be used in the given application. Keep in mind, this testing in the SDLC process is manual testing, or we can say unit or functional testing, not the security testing that we do in the VAPT phase. That comes as the next part after all of these steps or the phases are being complete in the SDLC process, which we are going to see next after we complete this. All right, so moving ahead to the fifth phase, which is basically testing. We have understood testing. Now moving ahead to the deployment phase, in which we deploy basically the beta version, I would say, of the given application, which is under UAT or staging, which has been tested and identified if everything works fine as intended, and then it has been after it has been tested, it goes for maintenance, in which we regularly, the organization or the development team would update and maintain the given software. Now, these all steps primarily contributes to the software development lifecycle, but a very important part to focus over here is VAPT is the next very important step that needs to be applied for the given vulnerability management tool that we have taken as an example for the SDLC process to understand that is being created. Now, the VAPT part remains a very integral part of the entire process, which will basically help us identify the gaps or defects that are being in the code level. So we will also do the static analysis part over here to identify if there are some insecure coding practices that has been done, or the vulnerable part of the code which can be replaced with better secure practices, or maybe replaced with the help of better dependencies, modules, libraries, etc. So that is the static analysis part. And the second part is going to be the dynamic analysis part, in which we would identify in runtime if any gaps or defects can be identified in the vulnerability management tool. Let's say, for example, the vulnerability management tool is available to be logged in from remotely over cloud. Now, it allows any user to log in with an incorrect password. Let's assume this, okay? And this defect was not identified while the code was written or while the SDLC process was completed. In the VAPT phase, when this was identified, that any user can identify the given vulnerability management tool's public URL because it is publicly accessible. Let's assume this. And while we log in, if we manipulate the response from false to true, we are able to log in the given application. Now, this can be really dangerous. Why? Because a vulnerability management tool can have the entire list of gaps for the given organization. So an attacker can utilize this very, very critical information to identify the weak points of the given organization in the application, software, network, etc., and then exploit it to gain or to make more damage. And here the impact would increase drastically. So we can understand that due to one defect that was in the application's code, in the authentication mechanism that was implemented, it led to a very big vulnerability later on. So I hope participants have overall understood about the SDLC process and how important it is to integrate the VAPT after on the once the application development has been completed, to avoid those different types of attacks in future. So I'll just go back to the chat box to see if all the participants are with me so far and is able to understand. You can please let me know in the chat box by typing a yes if everyone is with me so far, or any queries. Okay, thank you. Thank you. Thank you. Okay, perfect. Now let's go back to the presentation. Thank you so much for your acknowledgement. How VAPT can be helpful for SDLC. We have already understood with the help of the vulnerability management tool example. Let us understand this in more detail now. Okay, so here I have depicted the most important points for which we would understand that how VAPT can be useful or very essential for SDLC process. The first is proactive security. This would The VAPT would allow us, or this step would allow us to mitigate vulnerabilities in a given time, ensuring robust security from the start of the given application. So here, this would allow the organization to identify the given defects or gaps in the code level itself. Now, this can be an added advantage for the organization moving forward for other applications as well. How, if you might ask? The VAPT can help the application developers understand the code defects that have been noted down or given as suggestions by the application security team or the VAPT team, so that those suggestions can be implemented directly in the SDLC process or can be a part of the standard operating procedure for the next application that is going to be developed by the given organization. Due to this, the organization can save their costs drastically, can save their applications efficiency, wherein the developers do not have to rewrite the code from scratch every time. So the developers would automatically understand, oh, these are the some of the secure coding practices that needs to be implemented in the code level from the first phase in the SDLC process, and they would stop or avoid these bad coding practices or other such practices which can lead to those severe vulnerabilities that have been identified in the later stage. So this helps in proactive security. It is cost efficient, strategic risk management, because it minimizes the exploitation rate for the given organization, and that's very obvious. If the application passes the VAPT checks that there are no gaps, no defects, directly it helps the organization to better manage the risks that the organization would have open in the attack surface for the given organization on public internet. Next is regulatory compliance. That is very obvious. Uh, Identifying the defects, fixing them in a timely manner through secure coding practices, implementing those directly in the SDLC process would help the organizations to be more compliant, I would say, in regards to various compliances that the organization would have to follow. Security awareness, this would help the developers who work, I would say, separately would now benefit from the VAPT testing process directly, which is now a part of the application development or implementation phase. And due to this, the developers would have a different approach and a mindset of secure coding, which would directly be helpful for the application development phase, because their mindset now would be using better dependencies or maybe secure dependencies, not using vulnerable functions, code, etc. Next is quality assurance. This would help us the organization to maintain the software quality by addressing all the risks during the development phase itself. Trust and reputation, that is byproduct of, I would say, if we do a strategic gap assessment in the given application, then trust and reputation is the byproduct of it, which means lesser the number of defects identified, higher the trust and reputation would go for the given software or the given organization. Next is continuous improvements. Now, due to the fact that continuous VAPT cycle that has been performed and whatever outcomes are being fed to the developers, so it will basically become a feedback control system for developers, in which the developers of the given organizations implement those given suggestions not only after the applications have been developed, but in the SDLC process itself, that can bring continuous improvements in the kind of applications or at the frequency when the applications are being developed of the given organization. And this continuous improvement can directly help the organization to reduce cost, increase efficiency, boost productivity, etc. Next is timely resolutions. Now, due to the fact that the strategic gap assessment has directly been implemented in the SDLC process, where the VAPT swiftly would address the vulnerabilities, or less number of risks would be identified, maybe low or informational risks would be identified, because the major part of the higher critical vulnerabilities are being handled by the application team now. So timely resolution would help. There would be less burden on the given development team to maybe mitigate or revalidate or fix those vulnerabilities in the patch management stage. And adaptive security. Adaptive security primarily means making the software much more resilient with different types of attacks, or I would say different types of evolving threats that happen. So if the developers have a clear mindset in which they implement the secure coding practices in the step one only while they perform the given steps for the SDLC, then the applications would be much more secure, and there will be an adaptive security environment that would be created automatically. Now here, uh, let's understand about and weave into the secure coding practices for developers. Here are some of the secure coding practices that we can see. But before we jump to the secure coding practices, I would like to give a demonstration quickly so that we understand about what kind of secure coding practices can be identified in given applications, how a simple gap assessment can lead us to a vulnerability that could be identified into it, and then how it can be fixed. Okay. So for the demonstration, I have hosted a local application in my system using a local PHP server. Now the application is running over here, okay, on my local server. This is the application which is written in the programming language, which is PHP, as we can see over here. And here we can see welcome to level 2, no results related to one were found. So there is basically a simple input box which is basically taking an input, and there is a button which is search button, and there is an image over here. So the amount of characters that I input over here is being counted and printed over here. Okay, so we can see the payload length is 3. So this is a simple application which takes an input from you and prints counts the number of input characters and prints it on the screen. Okay, so if I go here and search HELLO hello, so we can see over here there are in total 5 characters. So we can see the payload length is 5, and we get a message over here, no results related to hello were found. Now if we try to understand the code over here of what is happening, the application is directly taking the input from the user. The application is written in the programming language PHP, is taking an input from the user and then printing back, or I would say echo back or reflect back the input that has been provided on the application's front page, as we can see over here. So if you say hello, we can see hello is been printed over here, and the characters are also being counted. Now let's go ahead and examine the code. So I'll open up Visual Studio Code, and before I open that, I want to say that there is a extension which I have installed, which is a free extension known as AppScan. It's a free community-driven extension which is available to be installed from the VS Code App Store. So I'll go to VS Code App Store and I'll search for HCL AppScan Code Sweep. This is, again, as I said, it's a free and a community-driven project, and this can help us identify static code-based vulnerabilities. So I'm going to search for this and I'm going to install it. You can see I've already installed it. Now, the AppScan extension can support developers while building the projects from scratch in the SDLC phase, can identify if there are any misconfigurations, or if it is the code is being written in an insecure manner, or if there is a dependency which has been installed which is vulnerable, etc. So we can see this supports various different types of languages, from Android to ASP to C, C++, JavaScript, we are going to examine PHP right now, and you can see it supports various different types of languages. So I have already installed this. It automatically will get enabled, and you can go ahead and see the test cases that it identifies in the static analysis part of the given application. So we can see here in the static analysis part of the given application, it identifies these all issues. For example, if a developer, let's take a very simple example. If a developer makes a mistake in which he has hard coded the username and password in a comment in a given page or a uh, part of the HTML page or a PHP page. So here we can see hard-coded credentials detected. Would this part, or basically this test case, would identify the presence of any credentials or usernames and password that has been hard-coded in a application which is going to be pushed on the production server for public use. Here we can see similarly there are different types of test cases which are being noted down over here. This was one just such example. If you want to go ahead and read, you can read more about it by clicking on the I button. And here we can see how it identifies if any given information is there. What is the fixed recommendation? Remove all hard-coded passwords from the source code. And there are some related articles as we can see over here and references which are related to OWASP. OWASP stands for Open Web Application Security Project, which gives the I would say outline and guidelines for application security testing. Now here there are also mitigations and best practices that needs to be done and developed or needs to be implemented by developers to make sure that the applications are not vulnerable and secure. So all of these test cases that we see here are based on the OWASP standards only. So if I go here and click this, it will open up the OWASP. Yes, the OWASP uh, guidelines in which we can see the use of hard-coded password. So if we go here and see the use of hard-coded password increases the possibility of password guessing tremendously. What are the consequences? The platforms, the severity is high, likelihood of this getting exploited is high because any attacker could utilize and exploit it. What are the risk factors? The examples. So here we can see there is a password. There is a string compare feature which is used in C. So we can see string compare has been used, which compares the password with, and the password is mu over here. In Java, we can see if password equals to mu, return 0 or return 1. So there is again a check-in condition over here in Java, and the password is being hard-coded over here. Okay, and other information related to it has also been written over here. So this can be an excellent resource for developers to get a reference to for different types of test cases. Now, let's come back to the given application that we were on to. So we are onto this application, and when I enter hello and search, the application reflects back the data on the given screen and counts the payload characters. Now let's go ahead and examine the source code. So the page is level2.php. So I'm going to go to VS Code, close this, and go to level2.php. Okay. Now once I'm here, I'm going to see the code. So I can see this is the code which has been written over here, which is level2.php. And I'm going to examine this code. Okay, so let's skip this HTML part. Okay, window.alert equals to function, and there is confirm, okay, which says window.location.href attribute level3.php. This is also fine. Then this, okay, so there here was a JavaScript. Then the title gets closed. Then the head gets closed. Let me just zoom this a little bit more. Yeah. Now, here comes the most important part for us, which is the PHP code, as we can see over here. Okay, so this is the PHP code. Now, if we see here, this given line is being highlighted, if we can see, and this has been highlighted with the help of AppScan. Now, AppScan says this is a high issue that has been identified in the code, which says potential user control data within PHP converted to HTML. So it says that the user control data that has been passed, which is hello, within PHP is now been converted to HTML without any kind of sanitization. Let's click on view problem. Okay, so here we can go ahead and read about it. Now we can also go ahead and read the same thing here. Okay, so let me just at the bottom. Okay, so when I go here and click this, we can see, okay, this is the issue that has been identified. Let's go ahead and click the open the issue details. Now when we open the issue details, we can see this issue is referred as cross-site scripting. So I'll go to Google and I'll search for cross-site scripting on OWASP. Okay, and this is, I would come to know, okay, so cross-site scripting is a vulnerability that has been identified. It is a type of injection in which malicious scripts are injected into otherwise a benign and trusted website. Okay, so this is a type of injection based vulnerability that can occur when the input that has been passed by the user is being directly taken into an HTML context without a sanitization, which is very interesting. Now, if we go down, we can see some payloads as well. So here we can see the XSS attack may be conducted without using script tag and other tags as are being written over here. So let's go ahead and try to see if we can perform really an XSS attack over here. Is the code really vulnerable? From the code static analysis, have we really identified a flaw or a gap or a defect which is really vulnerable or a true positive bug? So we can go ahead and read the fix later on external references to XSS JIT later on. But let's try to exploit this. Okay. So here we can see the input name equals to keyword and value equals to $string. So the keyword is going to basically take your input and pass it to HTML directly. Okay. So instead of passing hello there, let's pass something else. Okay. So what I'm going to do is I'm going to pass a simple JavaScript. So a simple JavaScript will start something like this: script alert and script tag close. Okay, let's copy this, go here and paste it here. Okay, so now we'll paste it here and hit enter and let's see. Okay, we did not got a alert as such over here. Let's go ahead and examine the code once again. Okay, so yeah, upon examining the code, we can see that the input that is being passed, yeah, did not execute the script tag for us automatically here. Now, what we would do is we will replace this with a different payload, which is image payload. So let's say image source equals to X on error equals to confirm 1. Okay. Now we are specifying one image to be loaded from a source X. X is not a valid source. So we are using an event handler which is on error, because we know we are going to get an error because the image can never be loaded from X. Hence we are saying on the error, please confirm, or let's say alert 1. Okay. Let's balance this payload, paste it here, hit search, and we can see we got an XSS. Okay, let's do this once more, paste it, hit enter, and we can see we got an XSS successfully over here. Okay, and yeah, this alert box confirms the presence of the XSS vulnerability in which the attacker was able to induce or inject his malicious payload in the given application. And once the attacker was able to induce or inject his malicious payload in the given application, the application executed that code, due to which the XSS appeared over there. Okay. So I hope participants were able to understand this practical. If there are any questions, any queries, you can please ask in the chat. The test cases are automatically generated by AppScan. Yes, these test cases are automatically generated by AppScan, and the test cases also keeps on updating over the period of time, and AppScan will automatically download those test case signatures within itself, and then it would automatically identify it on the given source code while we perform the static analysis. I hope this answers your question. There is one more question: penetration testing or penetrating methodology. So penetration testing or penetrating methodology, if I would say, would have a lot of steps involved. In brief, if I would like to answer, the first step can be the first step can be identifying. Just write it down here. The first step can be identifying all functionalities of the given application. Okay, so the functionalities can be sign up, login, print, view, generate PDF, etc. Okay, identifying all the given functionalities and testing those given functionalities if they are working in an intended manner or no. Okay, testing the given sign up and sign in functionality to see if there can be authentication bypass test cases or no. Third, if the application has multiple roles, user role, admin role, super admin role, maker role, checker role, then check for broken access control. Broken access control means if a normal user can access the higher user's account or no. Okay, and other test cases will be based on OWASP top 10. So I've already shown a presence of I've already shown the reference to OWASP. So here we would see the top 10 list of vulnerabilities that can be identified in the given application. So this can be a very simple and a brief methodology, if I would say, for testing a given application. Testing the given application and identifying the given defects or gaps on the given software or the application. Can we grab the result of test cases exporting in format like TC with the result? I think you can get all of these test cases from here, but I'm not sure if you can export the test cases from here directly. Okay, but still you can check out on the given website if AppScan allows you to basically generate the test cases as well, and export those test cases if you want from here. It definitely allows you to export the results. So for example, whatever the issues have been identified will keep on generating in the problems column here, and you would be able to see basically the issues that have been identified, and then not only the issues that have been identified, also suggest the recommendation that needs to be applied over there. So I can say open the issue details, ask the community, or what is the basic fix that can be applied. So we can go to fix recommendations and we can see, oh, this is the fix recommendation in which get link, and here we see get link with filter sanitize the URL. So whatever the input was there, that needs to be sanitized for known malicious characters. What are some of the known malicious characters? Special characters that induce JavaScript, etc. So this was one of that thing. Okay. Yeah. Why did the script tag not execute? It was also an XSS. Yes. So for the specific this level, so this is basically an XSS lab. So for this specific lab in the code, it is blocked that the script tags would not function. Okay. So similarly, if we move on to the next part of the lab, we would see that other functions are being blocked as well. For example, if I go to level 5, we can see if we input script, it will get replaced by SCR_IPT. Okay, so script tags will not work over here because the HTML says string replace script with SCR_IPT. So your script tag will not work. So you have to use a image tag, audio tag, video tag, SVG tag, etc. to perform the XSS. And similarly, you would perform other test cases over there. I hope I was able to answer all of the questions. You can please let me know in the chat so I can proceed. You're welcome. Okay, I hope everyone has understood the demonstration as well. Now, what are the key learning outcomes or objectives from this demo or this demonstration? The first thing is we were able to identify a given application which takes our input, prints it on the screen and counts the number of characters. We identified while we were doing the source code analysis that there is a potential uh, problem in the given code that we identified with the help of AppScan, and it highlighted that the application is given the application that we see is basically vulnerable to XSS. Yeah, cross-site scripting. Now, as the application was vulnerable to cross-site scripting, we saw how we can exploit it. So we took a XSS payload from OWASP. We went to OWASP, read about XSS, entered it in the given payload, a parameter keyword, and we were able to successfully see that we were able to make the application execute attacker supplied code, and it gave us a real XSS. And the last key takeaway here for the development phase is that the developers can now understand the potential uh, places where these vulnerabilities can be fixed in the code and learn from the fixed recommendations so that they block characters like special characters or use HTML special characters or HTML entities directly in their code so that they automatically encode or sanitize the given HTML characters to avoid these types of attacks. So this can directly be implemented in the SDLC phase by the developers so that the vulnerabilities get patched over there directly. Okay, so this was one of such example or demonstration that I wanted to show all the participants so that they can better understand that how VAPT or security testing can directly benefit in the initial secure coding or SDLC process directly. Okay, so the kind of vulnerability that we have seen or the test case that we have seen, which was XSS, which induces the uh, attacker supplied JavaScript code getting executed. There can be different types of vulnerabilities which can lie in authentication, hard coding secrets, which I've already discussed, error handling and session management as well. So the one which we have seen right now was for the input validation attack, which allowed us to perform an injection attack, and it was a JavaScript injection attack as we learned from the given OWASP website. There can be different test cases that AppScan can identify and that can be fixed by the developers in the SDLC phase itself related to file uploads, encrypting the data from client to the server, encrypting sensitive information like KYC data, card details, etc. Security audits, XSS prevention, CSRF protection can be helpful. Now here is a case study that I would like to discuss. The objective of this case study is to strengthen the application security through VAPT for the given organization. This VAPT exercise not only should identify the gaps and defects, but also should help the development team to implement the learnings and outcomes in the SDLC phase to be more robust and resilient in the next phases of the application development. So here we have taken an example of an ABC company or ABC corporation, which is an e-commerce platform, and they want to basically perform application security testing and identify all the issues in the VAPT project or the VAPT phase. The objective of the organization is to identify and mitigate vulnerabilities in the platform, ensure they are compliant with, if they're e-commerce and they are using payments, they are compliant to PCI DSS. If they are in healthcare, they are compliant to HIPAA and other such compliance security standards. And the objective is to maintain the overall good security posture so that there is no cyber attack that happens on the given organization. Now, in the implementation stage for the organization, if they don't have a security team, they would have to engage a cybersecurity firm for doing the VAPT here in this case. Collaborate with the internal team to define the testing scope for the external agency or the external organization for VAPT, and conduct VAPT across all of their applications, or I would say digital assets that they want to secure. It can be API, web application, database, network infrastructure, etc. What will be the result of these activities that the organization would do? The results would be something like this. Early detection of critical vulnerabilities that can be potentially exploited later on by attackers. Second, cost-effective resolution. These vulnerabilities now can be fixed in the development phases moving forward in the next life cycle, where there will be a next update life cycle of the application, or if another applications are going to be developed, then it can be a cost-effective solution of not reworking on those things in the patch management phase. Third, regulatory compliance, which is basically complying with the security standards and regulations. Security education, which is basically enhancing the security culture between the developer teams and the security teams, so that they follow up-to-date standards, they follow up-to-date security practices that are being followed in the industry. And definitely customer trust, which is the byproduct, or I would say the outcome of the entire VAPT exercise, that is going to be helpful for the organization, minimizing the overall risk in the given organization's applications. Now, let us assume there are some vulnerabilities or gaps that has been identified. So in the recommendation and the continuous improvement part, there would be suggestions which says there should be regular VAPT occurrences that should be happening. Why? Because of the continuous changes in the technology. It is very fast. In cybersecurity specifically, if there is an application, let's say Apache server version 5, maybe after a period of a quarter or 6 months, Apache version 5 might have a critical vulnerability identified in itself. So a regular testing needs to be done for the application software or components that are being used apart from the secure code that is being written. Okay, so the components needs to be checked continuously, and there should be a continuous improvement into that, or any new code change or functionality change should also be monitored over here. Second, integrating security directly in the SDLC to proactively make sure that we reduce the overall number of bugs or defects that have been identified, and conducting security training programs like these for the employees, for the developers specifically, so that they can understand the hazards of bad secure coding, or maybe implementing a dependency or pulling a dependency directly from untrusted source, etc. And lastly, the conclusion would be based on all of these steps that the organization has implemented, jointly would help the organization strengthen their cybersecurity posture, building a robust defense system, not only from the security standards, but from the production standard as well, which is the application development standard. Thank you, and I'm open for questions if there are any questions.